All right, so you've asked me about number 6. I'm not going to do the 6A that I need you guys to do on your own, but I will do B and C if you need me to. So how do we sketch this graph of the absolute value function stating intercepts and domain and range? Okay, so what you want to remember here, remember the whole piecewise function thing, right? This graph right here looks an awful lot like y equals regular old x plus 5. Screen share, is it frozen up here? Frozen. Okay, so this graph in B, okay, letter B, looks an awful lot like this graph. But what we know is because of these absolute value signs that wherever this graph dips below the x-axis, we have to flip it up, okay? So it might be a good idea to start with this graph, okay? And what do you know about this? The slope is 1. The y-intercept is plus 5. So I would start there. I would say, okay, 5. And the slope is 1. So in a rough sketch, again, just a rough sketch, the graph looks something like this, okay? And this graph would also go down here, and it would extend below the x-axis like this. Now, with the absolute value, though, what we know is wherever this touches the x-axis, and we can find that out pretty easily, right? It's a slope of 1. So if I have this point, I know if I go down 5, I have to go to the left 5, right? Because a slope of 1. So that means this x-intercept is negative 5, 0. And the absolute value, which maybe we'll do in red, looks the exact same on where the graph is above the x-axis, but then it flips and it mirrors the negative part like this. So there's the graph. Here's the x-intercept. It's the same as the non-absolute value function. So x-intercept here for this one is negative 5, 0. And what else do we do? Oh, the range. Well, the range is r equals, brace, y is greater than or equal to 0. And that's all you need to put in there. Okay. Question?
How do you know that it goes down into the left?
How do I know that it goes down and to the left? Sorry, the line itself?
Yeah.
Okay, so how do I know well, if I started with the original one, because this slope, okay, is a positive 1, that means that from any point, you go up 1 and to the right 1, and then you plot another point that's on the line. Up 1, over 1, up 1, over 1. So to find the slope, or to find the x-intercept, what you kind of want to do is you can trace that back down. So down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, down 1 to the left, and keep going until you hit the x-axis there. Or like I did, I know that the slope equals 1. So if I go down 5, I have to go to the left 5, and that would be right here. So that gets me to this point. If it's a negative, like this here is a negative for C, is a negative slope, then I know that that line goes down like this. It goes down from left to right and has a intercept of negative 6 and a slope of negative 3. So for C, the absolute value here would be the same as the graph that's above the x-axis, but boom, there's my x-intercept, and now everything else is reflected up. Okay, so the black graph here now is the absolute value for C. And then you just have to do a little bit of calculation here to find the x-intercept, right? Over 3, up 1, that sort of thing. Over 3, up 1, over 3, up 1, and so on.